Welcome everyone to my channel. Question number 201. Steam curing is not recommended for use with high alumina cement. Option C is right answer.
Because it can lead to rapid hardening, potentially causing durability issues like expansion, cracking, or spalling, and can also alter cement's reactivity, leading to strength loss over time.
Question number 202. According to IS 456 1978, minimum period stipulated for moist curing of concrete using ordinary Portland cement is 7 days. Option B is right answer.
Moist curing of concrete is done by spraying water to it or by ponding or canvassing it.
Question number 203. Curing period required is minimum for the concrete using rapid hardening cement. Option C is right answer.
Rapid hardening cement requires shorter curing period than ordinary Portland cement, and it is used where early strength and early setting is required.
Question number 204. For reinforced concrete exposed to sulfate attack, minimum grade required is M20. Option C is right answer.
Sulfate attack occurs where concrete is exposed to sulfate containing environments like soil or water. This can lead to cracking and deterioration of concrete. As per IS 456 2000, the value will be M25 for moderate exposure condition and M30 for severe condition, M35 for very severe condition.
Question number 205. According to IS 456 1978, the total sulfate content as percentage of mass of cement in concrete mix should be limited to 4. Option C is right answer. Question number 206. According to IS 456 1978, the total chloride content as percentage of mass of cement in concrete mix should be limited to 0.16. Option C is right answer. And 0.06 for pre-stressed concrete. 207. According to IS 456 1978, the maximum water cement ratio in plain concrete to ensure durability in mild exposure is limited to 0.70. Option D is right answer. Question number 208. To ensure durability for similar conditions of concrete, water cement ratio in reinforced concrete as compared to that in plain concrete is less. Option B is right answer.
From the previous table, we will get the idea the water cement ratio for RCC is less than that for PCC.
Question number 209. For a given degree of hydration, the effect of increasing water cement ratio in concrete is to increase the permeability. Option A is right answer.
Generally, a higher water cement ratio results in more pores and permeable concrete.
Question number 210. For a given water cement ratio in concrete, with passage of time, the permeability decreases. Option B is right answer.
With the passage of time, permeability decreases as the ongoing hydration process of cement leads to a denser microstructure and reduced pore size into the concrete, making it less susceptible to fluid passage.
Question number 211. As compared to moist cured concrete, the permeability of steam cured concrete is more. Option A is right answer.
Steam cured concrete generally exhibits higher permeability, especially on the surface, as compared to moist cured concrete due to heat damage and pore coarsening that can occur during the steam curing process.
Question number 212. If the compressive strength of concrete determined from 150 mm into 300 mm cylinders is X, then the compressive strength of same concrete determined from 150 mm cube is 1.25 into X. Option D is right answer.
The value of compressive strength for cube is always 25% more than the cylindrical strength, as cube is a equally three-dimensional solid object compared to three-dimensional cylinder.
Question number 213. The compressive strength of concrete determined from 150 mm into 150 mm cylinder as compared to that determined from 150 mm into 300 mm cylinder is more. Option A is right answer. Question number 214. The compressive strength of concrete determined from 150 mm into 150 mm cylinders as compared to that determined from 150 mm cube is.
The compressive strength of cube will be more according to me, because if we compare, the contact surface area of cube will be more as compared to cylinder under the loading. Option B is right answer.
Question number 215. Assertion A. For determining an uniaxial compressive strength of concrete cube is a better test specimen as compared to the cylinder.
No, better test specimen for determining uniaxial compressive strength of concrete is cylinder, but cube strength can be done triaxially because it has equal dimension in three directions.
Reason R. Stress distribution is more uniform over the cross section of a cylinder as compared to the cubes.
Stress distribution is more uniform over the cross section of a cylinder because of absence of sharp corners in cylinders as compared to cubes.
So option D is right answer. A is false but R is true. Question number 216. According to IS 456 1978, if Fy is the characteristic strength of the steel and Es is the modulus of elasticity of the steel, then the maximum strain in the tension reinforcement in the section at failure should not be less than 0.002 plus Fy divided by 1.15 into Es. Option C is right answer. Question number 217. Design strength of concrete for limit state of collapse is taken as 0.FCK by R, where FCK is the characteristic compressive strength of concrete and R is the partial factor of safety for concrete. Question number 218. The limit state design of concrete for flexure, the area of stress block is taken as 0.36 FCK into XU. Option A is right answer, where FCK is the characteristic compressive strength of concrete and XU is the depth of the neutral axis. Suppose this is a rectangular RCC section of width B and effective depth small d, which is the distance from the extreme top fiber of the section and the center of the tensile steel. That is AST, and XU is the depth of neutral axis. This is neutral axis. This is the strain diagram of the rectangular RCC section. The maximum strain value at the extreme top fiber will be 0.0035, and at the level of tensile steel reinforcement will be 0.002 plus Fy divided by 1.15 into Es. And this is stress diagram. We know rectangular parabolic above the neutral axis. So the design compressive strength of concrete at the extreme top fiber will be 0.45 into FCK. Now if we want to calculate the value of tensile force at the level of tensile steel, it will be 0.87 into Fy into AST. Fy is the yield strength of steel and AST is the area of tensile steel. Okay, and above the neutral axis, the value of compressive force will be 0.36 into FCK into B into XU. B is the width of the beam, XU is the depth of neutral axis from the top fiber, and FCK is the characteristic compressive strength of concrete. Now, if we want to find out the area of stress block, this is the stress block, rectangular and rectangular parabolic, then we have to find out area of this block and area of this block. Now if we now if we add this area plus this area, the total area of this stress block will be 0.45 FCK into 0.42 XU for the rectangular section and 2/3 into 0.45 FCK into 0.58 XU for this rectangular parabolic section. So the total area of this stress block will be 0.36 FCK U. FCK. So the total area will be 0.36 FCK XU. Question number 219. Shape of the idealized stress strain curve for concrete as prescribed by IS 456 1978 is rectangular parabolic. Option C is right answer. Question number 220. In limit state design, under reinforced section is the one in which tensile strain in steel reaches yield value while maximum compressive strain in concrete is less than its ultimate crushing strain. Option A is right answer. Question number 221. Assertion A. According to IS 456 1978, over reinforced section are not permitted. Right? Reason R. The rarest ductile failure of the over reinforced section. No, ductile failure will be for under reinforced section where the quantity of steel is less than the balance section. But in case of over reinforced section, the quantity of steel is more as compared to concrete. So the section will fail by concrete, and as the concrete is a brittle material, so the failure will be brittle type. So option C is right answer. A is true but R is false and not correct explanation. Number 222. In limit state method, balanced design of a reinforced concrete beam gives smallest concrete section and maximum area of reinforcement. Option A is right answer. In the limit state method, balanced design of a reinforced concrete beam
is the one where steel yields and concrete reaches its ultimate strength simultaneously, results in the smallest concrete section and maximum reinforcement allowed by the IS code utilized efficiently, leading to a predictable failure.
Question number 223. In limit state design, limiting value of depth of neutral axis is 0.53 into D. Option A is right answer, where D is the effective depth of the section. Question number 224. In limit state design, the maximum limit imposed by IS 456 1978 on the redistribution of moments in the statically indeterminate beam is 30%. Option D is right answer.
In a statically indeterminate structure like continuous beam, when a beam starts to yield, reaching to its plastic capacity at a specified location, the bending moment can shift to the other section of the beam, which allows the designer to create more efficient and economical structure by utilizing the plastic capacity of the materials.
Question number 225. Percentage of steel for balanced design of a singly reinforced rectangular section by limit state method depends on. We know percentage of steel in limiting condition is equal to 0.36 FCK divided by 0.87 FY into XU limit by D. D is the effective depth of the section. XU limit is the depth of neutral axis at limiting conditions, and FCK is the characteristic compressive strength of concrete, and FY is the yield strength of the steel. Okay, so the percentage of steel depends on small d, that means geometry of the section, FCK characteristic compressive strength of concrete and yield strength of steel. Okay, and E, the modulus of elasticity of steel is 200 GPa for maximum type of steel, so it is constant.
Option C is right answer 1, 2, and 4.
Question number 226. In reinforced concrete, pedestal is defined as a compression member whose effective length does not exceed its least lateral dimension by 3 times. Option B is right answer. Number 227. Maximum strain at the level of compression steel for a rectangular section having effective cover to the compression steel as small d and neutral axis depth from the compression phase as XU is. Option A is right answer, 0.0035 within bracket 1 minus small d by XU. This is the beam section of with B and effective depth small d, which is the distance between the extreme top fiber and the center of the tensile reinforcement, and small d dash is the distance between the extreme top fiber and the center of the compression steel. Okay, and this is the strain diagram. Suppose the strain at this level epsilon st, and strain we know at the top extreme fiber will be 0.0035. Now we have to find out the strain at this level, at the center of the compression steel, at this level. This is suppose epsilon sc, and xu is the depth of neutral axis at limiting condition. By this similar triangle we can write this value divided by this distance xu, and this strain value epsilon sc divided by this distance, that is xu minus d dash. So if we simplify, the epsilon fc value will be 0.0035 into 1 minus d dash by xu. Question number 228. The diagonal tension which results in ultimate failure due to development of diagonal tension cracks depends on shear span and effective depth. Option A and B both are correct. Option C is right answer.
The tension which is caused in the tensile zone of a beam due to shear at or near the supports is called diagonal tension. The ratio of shear span, which is the distance between the supports, to the effective depth, which is the distance between the extreme compression fiber to the center of the tensile reinforcement, is a critical factor. A higher ratio increases the risk of diagonal tension. Shear reinforcement is provided in RCC beam to take up the diagonal tension and prevent the cracking of the beam.
Question number 229. Flexural shear failure in a reinforced concrete beam occurs under large bending moment and lesser shear force and results in crack which are normally at 90 degree with the horizontal. Look at the diagram. The crack pattern for a simply supported beam is shown. For this beam, the diagonal tension crack at the support, this is at an angle, okay, but at mid span when the crack is vertical at mid span, okay, this is flexural crack. Number 1, at or near the mid span the cracks will be vertical, which is the flexural cracks due to bending along, and number 2, at or near the supports the cracks are inclined at 45 degree, which is the shear or diagonal tension cracks, and in between the supports and mid span the cracks inclination may vary from 45 degree to 90 degree gradually, which is the flexural shear cracks. Option A is right answer. Question number 230. For a continuous RCC beam, match list 1 with list 2 and select correct answer using codes given below.
So consider a continuous beam ABCDEF, ABCDEF with end span AB and EF and intermediate span BC, BCCD. Now if we take an imaginary hinge at X of the span BC and apply a pair of positive bending moment adjacent to the both side of the hinges, the deflected shape of the beam will be like this. Okay, so from this deflected shape we can say to get maximum sagging moment the live load should be placed the same span as well as the alternate span. Okay, and similarly we will get maximum hugging moment for live load placed at the adjoining span, this span and this span. This two span is the adjoining span as well as alternate span. Okay, if we consider a continuous beam MN, OP, QR, S and take an imaginary hinge at point P with a pair of negative bending moment to the both side of the hinges, the deflected shape of the beam will be like this. Okay, from the diagram we can say for maximum hugging moment at support, the live load should be placed on the adjacent span on both side of the support as well as alternate span. This is alternate span and this is alternate span, and these two span is the adjacent span on both side of the support. Option A is right answer.
Question number 231. A beam whose effective span is L, effective depth is small d and overall depth is capital D shall be deemed to be a deep beam when the ratio of L by D is less than 2 for simply supported beam and L by D is less than 2.5 for continuous beam. 2 and 4 are correct. Option D is right answer. Number 232. The effective span of a D beam is taken as smaller of A and B. Center to center distance between the supports 1.15 times the clear span. Option C is right answer, smaller of A and B. Question number 233. For a deep beam whose overall depth is 5 meter and effective span is 6 meter, the lever arm for simply supported beam and continuous beam respectively will be.
As per IS 456 2000, in case of simply supported beams, the lever arm value Z is equal to 0.2 into L plus 2D, where A is the effective span of the beam and capital D is the overall depth of the beam. When L by D ratio is greater than 1 but less than 2, but when L by D ratio is less than 1, the lever arm value Z will be 0.6 into L. And in case of continuous beam, when the L by D ratio is less than 2.5 but greater than 1, the lever arm Z will be equal to 0.2 into L plus 1.5 into D. And if L by D ratio is less than 1, the value of Z will be equal to 0.5 into L. So from the question, for simply supported beam, the value of effective span L equal to 6 and overall depth D equal to 5 meter. So if we make the ratio L by D, it will be equal to 1.2, which is less than 2. So the lever arm Z will be equal to 0.2 into L plus 2D. So 6 plus 2 into 5, Z will be equal to 3.2 meter. And for continuous beam, if we make L by D ratio, it will be 1.2, which is greater than 1 and less than 2.5. So the lever arm value Z will be equal to 0.2 into L plus 1.5 D. So if we put the value, we will get Z equal to 2.7 meter.
Option A is right answer. Question number 234. The bending moment at the mid span of a square vertical bunker due to a lateral pressure P per unit area is.
Bunker is a RCC storage structure used as bins, used to store coal, cement, grains, etc. The bending moment at the midspan will be PL square by 24 and PL square by 12 at the corner or edge.
Option C is right answer. Question number 235. In silo walls, the compressive stress on the net concrete section deducting all openings should not exceed.
In construction, silo wall means the vertical walls of a tall cylinder structure used for storing bulk materials like grain, cement, coal, etc., designed to withstand the pressure exerted by the stored materials. And the value of compressive stress on neat concrete section will be 0.15 into FCK. Option A is right answer.
Question number 236. Which of the following theory is applicable for design of silo walls? Jansen's theory. Option A is right answer. Question number 237. To ensure lateral stability, the clear distance between the lateral restraints in case of simply supported and continuous beam should not exceed. lesser of 60b or 250 into b square by d. Option A is right answer. Question number 238. Consider the following statements in regard to silo and bunkers. In case of silos, due to their height and effect of wall friction, the horizontal pressure does not increase linearly with depth. So it is incorrect statement. Statement 2. The horizontal pressure on the wall of a bunker increases linearly with depth from top. In bunkers, since they are wider and shorter, the material behavior is very similar to soil. So Rankin's theory applies and horizontal pressure increases linearly with depth. So it is correct statement. Statement 3. The ratio of vertical pressure in silos at the time of emptying to that at the time of filling is less than 1. During emptying, the pressure in a silo decreases compared to when it's filled due to their reduction in material weight and changes in stress distribution. So the ratio of vertical pressure during emptying to filling is less than 1. So it is a also correct statement. Option B is right answer. Question number 239. For RCC bridges, the smallest span beyond which the impact factor is same for class A or B or AA or 70R loading wheeled vehicle is. So, in case of class A and B wheeled vehicles, the impact factor will be 0.5 when the span is less than 3 meter. Okay, and impact factor will be 4.5 divided by L plus 6 when the span of the bridge is less than 45 meter but greater than 3 meter, and the impact factor will be 0.08 for span greater than 45 meter. Okay, and in case of class A and 70R wheeled vehicle, impact factor is equal to 0.25 for span get less than 12 meter, and impact factor is equal to 4.5 by L plus 6 when span less than 45 meter but greater than 12 meter, and impact factor will be 0.08 for span greater than 45 meter. So we can clearly say the span beyond 12 meter the impact factor is same. This value 4.5 by L by 6 0.08, and for this class of loading impact factor 4.5 by L by plus 6 and 0.08. Okay, so beyond 12 meter span the impact factor value will be same for both class of wheeled vehicles. Option B is right as 12 meter. Question number 240. Match list 1 with list 2 in connection with moment capacity for different condition and types of slabs as per yield line theory and select the answer using the codes given below. List 1 types of slab and list 2 moment capacity. Type of slab equilateral triangular slab. The moment capacity WL square by 72, and simply supported square slab it is capacity is equal to WL square by 24, and for square slab fixed at all edges the moment capacity is WL square by 48. Question number 241. The purpose of lateral ties in a short RCC column is to avoid buckling of longitudinal bars. Option A is right answer. Question number 242. In a doubly reinforced rectangular beam the allowable stress in compression steel is less than the permissible stress in tension in steel. Option C is right answer. Question number 243. The side face reinforcement if required in a T-beam will be 0.1% of the wave area. Option A is right answer. Question number 244. Consider the following statements regarding the working stress design of under reinforced RCC section. The neutral axis depth will be greater than that of a balance section. No. The section where quantity of steel is less than the balance section is known as under reinforced section. The neutral axis depth will be less than that of a balance section. The stress in the steel in tension will reach its maximum permissible value first, right? The moment of resistance will be less than that of a balance section, right? On the tension side is also to be considered for calculating the moment of resistance of this section. As per IS code, the concrete on tension side is to be neglected. So option D is right answer. 2 and 3 are correct. So number 245. Which of the following sections of the equal cross sectional area can resist the torsional moment of the RCC beam section more efficiently when the working stress design is being adopted? A box section. Option B is right answer. Box section has greater torsion resisting capacity than others. Question number 246. Loss of stress with time at a constant strain is in steel is called relaxation. Option A is right answer. Question number 247. Deep beams are designed for bending moment only. Option B is right answer. Question number 248. If P is the pre-stressing force applied at a maximum eccentricity G at the mid span, figure 14.1, to balance the concentrated load W, the balancing load will be. So just consider this beam as a simply supported beam. Okay, so the load is at the center, so the bending moment will be at the center under the load WL by 4, and the eccentricity of stressing force P from the center is G. So the bending moment under the stressing force which will counteract the downward load, that is equal to P into G. So if we equate these two bending moment, bending moment under load and bending moment under stressing force, we will get the load is equal to 4 pg by L. Option D is right answer, 4 pg by L. Question number 249, in a check for development length LD shall not exceed M1 by V plus L0, where M1 is the moment of resistance of the section after bar curtailment, V is the maximum shear in the region of M1, and L0 is the L0 at the discontinuous end is. Option A is right answer, equal to the 12 phi. Phi is the diameter of the bars or effective depth D, whichever is greater. As per IS 456 2000, clause number 26.2.3, for curtailment, reinforcement shall extend beyond the point at which it is no longer required to resist bending for a distance equal to D or 12 phi, whichever is more, except at simple support or end of the cantilever. Question number 250, in the limit state design of concrete structures, the strain distribution is assumed to be linear. Option A is right answer.